Hey guys, we talked a little bit yesterday about parallel circuits. I want to go over that again briefly with some drawings because I want to explain it a little bit deeper. So let's draw a quick parallel circuit. We'll put our battery here and then add our node. I like to make an obvious node. I mean, you could just do something that's like a line that intersects like that. That's, to me, not obvious. So I try to make an obvious dot there to represent my branch or my node. I use both those words because they're used interchangeably in electronics. But we have different ways to talk in electronics, and node means different things. If you're talking to an IT guy, that would mean something different than somebody who is a astronomer. They both have very different meanings. So, but in electronics, a node is a junction point or a branch. So we have a parallel circuit here, and this is the negative side of the battery being the smaller line, and the positive side of the battery. Electrons flow negative to positive, and I'm going to take, try a different pen here of a different color. And I'm going to draw the current leaving here. And let's say we have these resistors, because of their value, we don't care what their value is yet, but these resistors are of different values. So as we have current going in this direction, some of it's going to go this way. Let's say that we have, I don't know, 2 amps going through this resistor. And some of them go this way. Let's say that we have 1 amp going through this resistor. Okay, coming out the other side of this resistor, we're going to have 1 amp. It doesn't change because here we have kind of a series circuit. It has just this path. But since we have a parallel circuit, we have multiple paths. So that 1 amp is going right here, and we have 2 amps still being used by this little branch, 2 amps. And right here, they join together, and we have 3 amps going back into the battery, which means that we're using 3 amps. Okay? I wanted to do this little short video to help you understand what a parallel circuit really does. And depending on what this is, this could be a 40-watt light bulb. This could be a 60-watt light bulb. Obviously, a 60-watt light bulb is brighter, so it's going to have more energy being used. It's going to have a brighter light. It means that it's going to have more current going through it. So as we work out the math in these things, I want you to remember that current does add up. So we have as a formula now called I total equals I1 plus I2. And this is current at the resistor, even though you can measure it anywhere in that branch. If you had more, so if you had a third resistor out here, this formula would extend. See that? If you had another one, and it just depends on how many resistors you have in your circuit. This would be R3, R4. Do that. They all add up. Whatever the current draw is of each of these resistors, they will add up to equal our total current. Our total current here is 3 amps because our current here on this resistor is 2 amps. Current here on this resistor is 1 amp. And we haven't included these yet, so we won't worry about those. And that equals 3 amps. I know the numbers are pretty simplistic. I did that on purpose because once you understand how simple a circuit is, then you can move on and advance from that. So I just want to make sure you got this, okay? Make sure you have this formula and you know what it means. I'm going to add one more thing. We're not going to do the resistors yet because it needs to be a video by itself because it has a whole different set of things to think about. But I want you to remember the next formula rule for a parallel circuit. We already know what the first one we talked about is the total current equals the sum of the current used by each resistor or load, depending on how many we have. And we're going to draw another circuit here. Simple circuit with just a couple parallel resistors. Remember what I said in the other video about how I like to draw them in parallel, physically in parallel with each other, just to help make the understanding easier, okay? So if you have 50 volts in your power source, it doesn't matter what size resistors these are, it doesn't matter what the current draw is, you're going to have 50 volts here and 50 volts here. And the reason that is because in this circuit, this is the same point electrically as any of this. See, none of this is going through a load. There's nothing to restrict this other than wire. And that's a whole nother thing. Wire is a different variable. We're going to assume, for the sake of this demonstration, that the wire has no resistance. And this is the same point electrically over here on this side, all of this. So if you were to put a multimeter, let's say you put a multimeter out here, a voltmeter, let's draw a fancy voltmeter, and you were to take one of the leads and connect it right here, and one of the leads and connect it right here, you're going to get 50 volts because this point here is the same as if you went right up next to the battery. Okay? And this one here, you could put this lead anywhere on this side and there's no resistance, so the value is not going to change. You're going to have 50 volts. So in a parallel circuit, our voltage is the same everywhere in the circuit. So voltage total equals your voltage at resistor 1 equals the voltage at resistor 2 equals the voltage at resistor 3, and on if you have more resistors. You may see me in the future write this formula like this: voltage total equals the voltage at resistor 1. But that's just too much. Hopefully you're starting to understand that I'm talking about the voltage at the resistor, not just voltage, willy-nilly. That's what this number means. This is R1 equals the voltage at R2. See that? Same thing with current. This is the current at resistor 1, resistor 2, and so forth. So that kind of wraps up this video. Hopefully that makes a little bit of sense to you. Parallel circuits does still a little bit of a curveball from what you've been taught in series circuit. Hopefully you're stable enough in series circuits not to confuse the two. Already you're starting to see a difference in the rules that the two have. So that concludes our current and voltage video. Good luck. If you have any need, any lack of understanding, we will have a Google Meet on Wednesday. But don't wait till then. If you need me, you can message me if we need to do a Google Meet before then, or if you just have a question you want to message me in Canvas or something similar to that, go for it. I'll do the best I can to help you out. If I need to do another Screencastify, which is what the program is that I'm using to make these videos, by the way. It's not just some word I made up. But if you need anything like that, let me know. I don't want you running around not knowing something that you need to know to make these things add up. Okay, so hopefully you took some notes and you did some drawings. We will do resistors on the next video, and that's it for this one. Thank you, guys.